So the third in the series, responses to exercise, the muscular ones. So we're going to look at, again, the acute responses, and hopefully you'll be able to recall and explain 3 acute responses to exercise. So there's the learning intention and success criteria. All right, there is a picture of me when I used to, when I used to lift. So we're looking at muscular responses. I just thought I'd chuck that in. I had more hair back then too. So one of the things that happens is there is increased blood flow. That's a pretty obvious one, given that activity, exercise, whatever it is, has started. There's going to be an increased demand for blood, because blood contains the oxygen. Oxygen is what the muscles use to create the energy. Or sorry, it's the energy that the muscles use for muscular contraction. So straight away, increased blood flow. There will also be a change in the recruitment and the muscle fiber activation. So basically what happens is the brain controls the motor units. So over here we have a picture of a motor unit. So it's the motor neuron and all the muscle fibers that it stimulates. Okay, so it could be 2 of these fibers, it could be 3, it could be 10. It depends on the size of the motor unit. And when any sort of activity happens, these motor units are the things that contract and basically make us move. They execute the movement. So they follow a set pattern. It usually starts with the smallest, slowest fibers first, and this is following the size principle, which if you want to read more about the size principle, it goes into it a little bit more detail on page 153 in your textbook. Then it's followed by the fast twitch fibers, the smaller fast twitch fibers, so fast twitch A, which they're the ones that can they can be trained, they can go between explosive movements and not as explosive movements. So they still use oxygen. And then finally it finishes off with the larger fast twitch B fibers, which they don't use any oxygen. Okay, so they're fully anaerobic. In terms of like how many and when they get activated and all that sort of thing, it's dependent on the activity. So if it's a explosive activity, then you will find, they'll still follow that same sequential order, slow twitch, fast twitch A, fast twitch B, but in terms of how quickly they're activated, it depends on the activity. So don't forget about the all or nothing principle. You learnt about it last year in theory in year 11. So the all or nothing principle basically talks about the muscle fibers and the motor units that are stimulated. They will either contract fully or they won't contract at all, based on whether or not the threshold is crossed. So another acute response to exercise, to physical activity, is the muscle energy stores. Obviously you are, completing some sort of activity which is going to decrease your fuel stores. Okay, it's just like driving a car. It's like, using a battery operated device. You're using the energy within those stores to power whatever you're trying to do. Okay, so eventually the energy is going to go down and down and down and down. So if you look at the graph on the right hand side of the page there, you can see that there are 2 activities, all right? And it also looks at the glycogen content within the body or within the muscles. Okay, on the left graph you have a sprint bout. Okay, so that's this one here. And then on the right hand side you have a prolonged running event. What do you notice about the 2 graphs? Okay, the sprint bout, they still have quite a, large muscular store of energy. I'm just going to look at the textbook here for a second. No, they still have I don't know, let's say 75, maybe 80% of their stores. Then if you look at the prolonged running, they might have maybe 5, maybe 10% if they're lucky, even less, depending on the the muscle fiber type. And the reason for that is because the endurance events, the longer running events, they use the glycogen stores and fat stores, as opposed to those sprint events that use the ATP PC stores. So that's why you're going to see a greater decrease in the muscle energy stores. I hope that makes sense. If you need more information about that, you can find it on page 153 and 154 in the textbook. So lactate and lactate inflection point. There are a couple of terms that you need to know as well. Obviously, when you're exercising, lactate, which is, or it's a byproduct of the anaerobic glycolysis system, is going to be produced. And we produce that at rest, but because the intensity is so low, the body is able to remove the lactate from the blood, so it's not really an issue. Okay, you can see the graph here on the right hand side. This is I would say a VO2 max test or something similar, whereby they're measuring the power in watts that's being produced versus the blood lactate. So you can see that it's relatively stable up until this point here. Okay, so like it said, during submaximal activity, it remains constant because the body's able to break down and remove it from the system. Okay, and this breakdown, it actually gives us more energy for muscular contraction. So that's when the body's working aerobically instead of anaerobically. But once this LIP, or the lactate inflection point, gets crossed, the lactate can't be removed, and it just keeps building up, building up, and building up, and the system can't keep up. So if we had to, mark on a graph where the lactate inflection point was, my dogs are playing. Where would you mark it on the graph? So it's that point where it increases exponentially. So we're talking, if we were talking about exponential numbers, I'm going to do a bit of maths here. Starts off at 2, then goes to 4, then 8, then 16, then 32, 64, 128, and so on and so forth. So it increases quite rapidly. So you would say for this graph, in fact, before I mark it, I want you to pause the video, or at least have a thought in your mind where you would put it if you were asked this question in an exam, which is quite possibly one of the questions that would get asked. Okay, so I would place it, that's not a very straight line, that's a terrible line in fact. Let's erase that and do it again. If I was marking the lactate inflection point on the graph, God, it's another terrible line, I would be putting it about here. Okay, because this was sort of the last reading, this one here, where the levels were relatively consistent, but after that it just shoots up. Okay, so that point there is the lactate inflection point, which is the point where the lactate can't be removed, it can't be converted, so it just keeps building up, building up, and building up. What I'll do at the end of this PowerPoint, or I might even put it separate too, I'll put a copy of a video where they actually complete a VO2 max test, and you can see the lactate building up in real time. So it's actually quite beneficial to look at. So another acute response to activity is the body temperature will increase because of everything that's going on inside the body. So the increase in metabolism, that's required to produce ATP in the muscle, heat is a byproduct of that. So this increase in metabolism comes with a cost. It comes with heat. And as a result of that heat being produced in the body, our body temperature increases. So how does the body respond to that? Well, there's a few ways that it does it. You may remember back in year 11 PE we talked about vasoconstriction, vasodilation. So that's vasoconstriction is when you're really, really cold, and so the body diverts the blood away from the skin. It keeps everything really close to the core. So you can try and preserve that body heat. On the opposite side of that, when you get too hot, the blood vessels all vasodilate, which means they divert all the blood flow to the surface of the skin. Okay, because the surface of the skin comes to contact with the, in theory, cooler air, and comes into contact with the cooler air, and that helps to cool the body down, along with splashing water and all that sort of stuff. So that is it's also one of the other body's responses is to sweat, and that sweating will also cool the body down too. Trouble is that heat can impact on performance, and we will look at that later on. Basically what will happen is if you end up sweating too much, then you're losing water out of the body, which has an impact on the thickness of your blood. We'll get into that later on, so don't worry about that. Chapter check time. What I want you to do is I want you to respond to the questions on the next slide. And you can also find those on page 156. What I'll do is I will put a link to those questions into Microsoft Teams. If you guys can complete those, that would be super. So let's do stuff. Let's do prac. If you can do this. Okay, so the prac, what I want you to do is I want you to do the best you can. I'm going to set this up so you will need to submit this one. Obviously you don't have access to all the tools. Some people may do, some people may not. I'm pretty sure none of you will have access to a spirometer, which is meant to measure your lung capacity, tidal volume, that sort of thing. So what I want you to do is just do the best you can, but you need to record a pre-exercise, then you need to do exercise for 10 minutes like it says, and then you need to do a post-exercise. So you'll need to record your heart rate, your blood pressure if you can, if you've got a smartwatch or something like that that allows you to do it. Temperature, hopefully everyone's got a thermometer. If you can't get a thermometer, then just don't worry about it. Respiratory rate, breaths per minute, you can do that the same as you would your pulse. Just take a sort of an estimate, take it for 15 seconds and then multiply by 4. And then your tidal volume, again, you can get an estimate. If you remember back to the acute responses to exercise for respiratory, it's the number of breaths times by 0.5 if you're a female and 0.6 if you're a male, and that will give you your liters per minute. So that'll give you your ventilation. There are questions over on the next slide. If you're wanting to use your textbooks, it's on page 158, but I will set something up that you can respond to on Compass and on Teams. Take your pick as to which one you want to use. Here's questions. You will need to submit this by the deadline. If you've got any questions, ask me. Yee. Finally, this is just a summary, so tying it all together. So the acute responses to submaximal and maximal exercises. Again, this is taken from your textbook and it's found on page 157 down the bottom of the page. But you can see all the responses. You have increased heart rate, increased stroke volume, cardiac output, so on and so forth. Just have a bit of a read of all of those and make notes as you need to. Thanks for watching, and I'll see you in the next video.